Okay, now that you've formulated the problem, collected data, and labeled it, what's the next step? It's time to train the model. Training the model is usually the easiest step in machine learning. Formulating the problem correctly requires domain expertise. Collecting the right data requires imagination. Labeling the data correctly requires either domain knowledge to identify proxy labels and to create a labeling system, or management skills to get the data labeled by a labeling service. When we train a model, we compare the prediction of that model against the label and use that information to update the model. And that part is basically just applying the standard machine learning algorithm to your data. Although it's possible to train a machine learning model only one time, the best performing machine learning models are trained continuously by taking a trained model from earlier and retraining it with new data. That's because the world is always changing, and only recent data will have a record of these newer changes. If you've built a workflow where humans label the data, then you've done half the work already. The next step is connecting their output to the model. And not only that, you've set yourself up for success by keeping humans in the loop. Many people assume that this isn't necessary, but for great machine learning, it absolutely is necessary to have humans in the loop. The process of training the machine learning model is easy. It's just standard algorithms. Now, don't misunderstand me. There's a lot of machine learning research to devise better and better algorithms for certain tasks. But for business problems, you will probably use standard algorithms. Now, your data scientist friends might disagree if you tell them that. So let's provide you with the names of some of these standard algorithms. So when they say they want to do a lot of work to find the right model, you can just name drop. Just use ResNet, you can tell them. So here are some standard algorithms that help with very common machine learning tasks. There are many others, but again, the point is to stop your data scientists from reinventing the wheel. The best kept secret in machine learning research is that most accuracy improvements come about because of better data. People create new algorithms all the time, and they compare them with previously known algorithms, but the improvements are very, very minor. Whether you use ResNet or some other image classification algorithm, you will get very similar accuracy. So just pick one, try it, move on. There are just a few standard algorithms for a few common machine learning tasks, whether you want image classification or you want text summarization. The repository for the text summarization model includes ready-to-apply machine learning models for a variety of tasks like sentiment analysis and speech recognition. The code is reusable, it's open source, so you can customize the code in any way. And although you can download the code to your machine and run it, it tends to not scale. Remember that machine learning works best when you have lots of data. And all that data will also have to be downloaded to your machine. It's far, far better to have your data on the cloud and simply submit a training job. This is called machine learning as a service, and all the public clouds have it. On Google Cloud, this is called Cloud ML Engine. On Amazon Web Services, it's called SageMaker. On Microsoft's Azure, it's called Azure Machine Learning Service. In all of these, you can launch a training job to train one of these standard machine learning algorithms on your own data. Then, the machine learning model learns to predict the label given the input. When the training is finished, the result is a file that has a set of parameters. And this is your trained model. So what do you do with this model file?